The fourth reaction is the Ullman reaction. First, have a look at its history. This coupling reaction is named after the German chemist Fritz Ullman. Introduction of the Ullman reaction. The Ullman reaction, also known as Ullman coupling reaction, involves the coupling of two aryl halides in the presence of copper to yield a biaryl as a product. The general format of the Ullman reaction is illustrated below. We can see that there are two aryl halides where X is maybe a iodine or a bromine molecule. In the presence of copper, it yields a biaryl as a product. Here I quote an example of that reaction. When orthochloronitrobenzene in the presence of copper bronze alloy at 220 degrees Celsius temperature is heated for 180 minutes, it will be converted into 2,2-dinitrobiphenyl and copper chloride as a byproduct. The mechanism of this reaction is given. It is basically a three-step mechanism. In the first step of the Ullman reaction, there is a formation of an active copper 1 species upon the introduction of the aryl halide to an excess of metallic copper under relatively high temperature, which is greater than 200 degrees Celsius. We can see in the picture. Then there is a next step 2. In the next step 2, the copper species undergoes further oxidative addition with another halogen molecule which is linking to the other two molecules. We can see here. There is an oxidative addition and a copper molecule is linking. Then there is a step 3. It is the final step of the Ullman reaction. The copper compound formed by the two aryl halide molecule undergoes reductive elimination, resulting in the formation of a new carbon-carbon bond, the two aryl compounds, as we can see here. So, the mechanism is simple. First step, oxidative addition. The second step is oxidative addition again. And the third step is a reductive addition. Next are the applications of the Ullman reaction. We can produce biphenyl from 2,2-diiodobiphenyl by using this reaction. This reaction can be employed for the closure of 5 membrane rings. Unsymmetrical reaction can also be achieved by using this reaction, and chiral reactants can be coupled into a chiral product by using this reaction. The fifth and the last reaction is Stille cross-coupling reaction. The history of this reaction is as follows. The first example of palladium-catalyzed coupling of an aryl halide with organotin reagent was reported by Colin Abram in 1976, and this was a reaction that yielded 7% to 53% of diaryl products. But in 1977, Migita published further work on the coupling of alkyl tin reagent with both aryl and acyl halides. The greater ability of alkyl group to migrate to the palladium catalyst allowed the reaction to be performed at lower temperature. So the yield for aryl halide ranged from 4% to 100% and for acyl halide ranged from 27% to 86%. Moving toward the introduction of the reaction. Basically, the Stille reaction is a chemical reaction which is widely used in organic synthesis. The reaction involves the coupling of two organic groups, one of which is carried as an organotin compound, which is also known as organotenase. A variety of organoelectrophiles provide the other coupling partner. The Stille reaction is one of many palladium-catalyzed coupling reactions. The general reaction of the mechanism we can see here, where X may be a halide, which may be chlorine, bromine, or iodine. Pseudohalides OTF, OPO, OR2, or OAC are the other. There is an ligand set and palladium catalyst we use, and the coupled products are R1 and R2. The R1 group attached to the trialkylene is normally sp2 hybridized, including vinyl and aryl group. Then there is a mechanism of Stille coupling cross reaction. First, there is an oxidative addition. The catalytic cycle involves an oxidative addition of an halide or pseudohalide to a palladium catalyst, transmutation of 3 with the organo reagent, and reductive elimination of 5 to yield the coupled product and the reagent generated by palladium catalyst. So here R1, R2 is equals to allyl alkenyl aryl. X may be a halogen and L may be a phosphine, which is a ligand, and alkyl may be a Me or Bu. First there is oxidative addition, and then there is a transmutation step, and there is a reductive elimination at last. Firstly, we will see what is oxidative addition. Oxidative addition to the 14 electron platinum 0 complex is proposed, and this process gives us 16 electron platinum 2 species. So, with the attachment of anionic ligands such as OAC, it accelerates this step by the formation of platinum OAC PR3 that make the platinum species more nucleophilic. In some cases, especially when a sp3 hybridized organohalide is used, and SN2 type mechanism tend to prevail. And then there is a transmutation step. The transmutation of the trans intermediated from the oxidative addition step is believed to proceed via a variety of mechanisms depending on the substrate and the condition. So the most common type of transmutation for the style coupling involves an associative mechanism. This pathway implies that the organostain normally and a tin atom bonded to an alkyl, anion or aryl group can coordinate to the palladium via one of the double bond. As we can see in the there is a cyclic mechanism and there is a open mechanism. These two steps can also be performed in the transmutation step. Then there is a reductive elimination. In order for R1 or R2 reductive elimination, these groups must occupy mutually cis coordinate site, and any trans adduct must therefore isomerize to the cis intermediate of the coupling will be frustrated. So cis trans reactions can also be formed in the reductive elimination step. Then at last, an extra ligand can associate to the palladium to form an 18 electron trigonal bipyramidal structure with R1 and R2 to each other in equatorial position. So the presence of bulky ligand can also increase the rate of elimination. Ligands such as fine with large bite angle cause static repulsion between L and R1 and R2, resulting in the angle between L and R group to increase and the angle between R1 and R2 to hence decrease, allowing for quicker reductive elimination. So there is an increased angle and decreased angle. Increased angle is between or above R2 and decreased angle is between R1 and R2. The application of the style coupling reaction are that this reaction has been used in the synthesis of a variety of polymers. However, the most widespread use of the style reaction is its used in organic synthesis and especially in a synthesis of natural products. So thank you. That's all from my side.